Hello, my fellow gnomes, and welcome to episode 22, which is the final episode in our tower defense series. Now, today we're going to be finishing up our shop. At the moment, we've got it all set up. We've got our GUI, we can buy items and equip them, but nothing we do here is going to save between sessions. So we're going to add some data saving. But before we do any of that, there's a quick little fix we need to make. So we're going to hit stop. And we're going to head over to our game place. We're currently inside the lobby. So if we go to the view, asset manager, and open up our places and head over to the actual game. And if we click play, I'll show you what I'm talking about. So there's a bit of a problem or a little bit of an error or bug, whatever you want to call it, with our code at the moment. So we've got map voting, which is counting down 3, 2, 1. But if we don't vote for anything, we're not going to have anything chosen. You see, we'll get this error down here. From 55, line 55 of the round script, telling us argument 1 is missing or nil, and it's just not going to bother giving us a map. So if we hit stop, what we want it to do is we want it to give us a map, even if there's no votes. So we'll head to the round module script, and if we find line 55 of our code, which is this line right here, which is it's looking for voted map inside of the serverstorage.maps folder, and the voted map is what is equal to nil, and so then we have to trace that logic back. Where does voted map comes from? It comes from the toggle voting function. So if we go to the round.toggle voting function on line 75, we can see it's all based on this here, this win vote being set to nil, and then it loops through all the votes so far, and then it assigns win vote to be whatever has got the highest score. But of course, if there's no scores, there's no highest score, and therefore win vote will stay equal to nil, and that will be returned back to that function. Hence, we get this error. So how about we add a little sort of quick if down here to check if there's not a win vote. So if there's still not a win vote, then we're going to want to assign one. Now, we could, just to keep things really simple, is we could just set the default value to something like grassland, which would be the name of one of our maps. In server storage, we've got these 3 maps. So we could just set it to that. But what we're going to do is we're going to set a random one instead. So to do this, we'll need a random number. So we can say local n equals math.random. And then normally you provide a number that you want it to be. So if I put 1 and 10, it will generate a random number between 1 and 10. Or I can just put the maximum number, in which case it will automatically assume somewhere between 10. Now in this case, I want a number for however many items there are of my maps. So the total amount of maps available. So what I can do is I can say server storage dot maps. Okay, we've actually already got this variable here, so that we can use this one here, this maps variable, serverstorage.maps gets children. So that gets me all the children of the maps folder. So maps, and then I want to say hashtag maps, because I want to know how many maps there are, how many children there are. And then I'll say that the random map, or the win vote, equals, so then I'll go to the maps variable once more, go to those children, and I'm going to retrieve number n. Okay, so a random number out of its children. And then I'll just say dot name. Okay, so the winning vote will equal the name of whatever the winning map is. So now if I click play, we'll wait for the countdown again. It's going to count down from 5 seconds. 4, 3, 2, 1. And what we got? Okay, we've got the Wasteland map. And if I was to hit stop and start again, we will maybe get a different map this time. Of course, it is random and it's only 1 in 3, so there's a chance we could get the same one all over again. Let's see, which one do we get? Okay, so we got the grassland map this time. So it is giving us a random map. So that's good. That fixes that potential little problem there. Only 4 lines of code, and that just fixes up that error. So we're going to click File and Publish the Roblox to save those changes. And then we'll head back into our lobby to start preparing for some data storage. Okay, so we're back in the lobby, and the good thing is that we've pretty much already written all of our script in the shop server script. Most of the hard work is done. All we're going to need is to add a few new functions. So we're going to need something to load the player's data, and we're going to need a function to save the player's data. Now, the player's data is going to be kept inside this data's table. Now, so far we haven't used this anywhere in the script. So if I control F for data, you see we haven't been using it. We've just been using this default data. We've just assumed that everyone has the same sort of data, which obviously isn't going to be the case. So inside of data, as we've talked about before, we're going to store a series of user IDs. So we'll maybe have a player called something like with an ID of 123. And then that will equal their own set of data, which will have various information like the default data. Okay, so we'd have something like this, ID 123, and then another one with, say, 456, and their own data would maybe they'd have a different amount of stars. So we need to populate all of this data. And so how we're going to do that is we're going to use something called DataStoreService, which will allow us to save the player's data between sessions. So when they play the game, exit, and then rejoin either a few minutes later or on a different day. So to use DataStoreService, obviously we'll start grabbing that at the top. DataStoreService equals game getService DataStoreService. And then we're going to need to create a database to store our data inside of. So we'll have a new line down here, and we'll just call this database. We'll set it to a variable, and then we get the data store service, and we use a function called getDataStore. This is where our data is going to be stored, and you can have multiple of these. So if you're going to keep a lot of data, you might want to have just one for experience, one for their inventory, and one for their finances. But we're not going to store that much data. This is kind of an example. So we're just going to put everything inside of this one database. And that's what we're going to call it. So we could have different ones with different names, but we'll just call this one database. And then once we've done that, we're then going to go about and actually put things into this and save them when they join or leave the game. But before we can do that, we need to actually enable the data store service. So if we come out of this and if we go to the home and we go to game settings, we need to go to then security and make sure we enable the studio access to API services, which will actually allow us to use data stores. So we hit save and then we'll be able to make those requests. And now we can respond to when a player joins the game. So for loading the player's data, we'll have a function called load data. We'll have the player as a parameter. And then we will have the save player's data function. So local function save data, which will also have the player. And then we're going to call it one of these functions depending on whether they join or leave the game. So if they're joining, we can use the player service player.playerAdded and connect that to load data. And if they're leaving the game, we're going to do the same thing. Players.playerRemoving, and then we'll connect that to the save data function. Just get rid of those brackets. There we go. So for loading the data, what we're going to do? Well, we're going to need to get the database, and we'll do something called getAsync. Before we do any of that, we probably want to bear in mind that when calling these functions, right, we're making a request to the server, and it's very important that it's successful, but it's not guaranteed it will be. There could be something that goes wrong with this request. If there's an error, then it could result in data loss for our game. We can't just rely on this connection to the database being successful. We need to do a little bit of error handling so we can handle different states if things don't quite work out perfectly. So to do this, we're going to wrap it in something called a p-call, and we're also going to repeat it multiple times. So we're going to have a variable called success, which will initially be nil, because we don't know whether it's been successful or not. And then we'll have a variable called player data. Okay, and that will be equal to nil at the moment as well, because we haven't loaded anything yet. And finally, we'll have one called attempt, which will be equal to 1 initially, but we're going to make a few attempts along the way. So we want to repeat multiple times. So we'll have a repeat until loop. This is a little bit like a while loop, but it will always run at least once. And then it checks the condition at the end rather than a while loop, which requires the condition to be true before it will do the loop. So repeat until we have success. So if success equals true, or you can just try until success, or the attempt number until that equals 3. So if we've had 3 attempts, then don't bother trying anymore. Now inside of this loop, we're going to use a p call, like I said, which is a protected call. And that allows us to run a function which may error, but if it errors, it's not going to crash anything. Instead, it returns 2 values. It returns whether or not it was successful. So we'll set success equals to the p call. And we can also return data from it as well. So the data we're going to return is, we're going to set that to player data. So what are we going to do inside here? We're simply going to run the get sync function. So we get the database, the one that we just retrieved, that data store. And we call get sync. And the ID we're going to use to access the data is the player's user ID. So player.user ID. And then once we've done that, we actually need to return this back to the function it's wrapped inside of. So we put return in front of it because we want to send back the data in the form of this variable right here. So now once we've attempted it, we don't know if it's successful or not. So we're going to add to the attempt. So attempt plus equals 1. And then we say if not success, if for some reason it didn't work, then we're going to warn. And for our warning, we can send the player data will actually tell us what the problem was. And then we can task.wait. We'll maybe just wait for a single heartbeat. So I could put 1 to wait for a whole second, but I'm just going to wait for a single heartbeat, a very short amount of time. And so that's our repeat loop, all done here. And then we'll check if we were successful. If success, then we can print data retrieved. And then we're going to need to choose whether we've actually got any data or not. Because it's possible if this is a new player joining the game for the first time, we might successfully connect to the database, but we won't actually have any data stored for this user ID. So this will still be an empty value. So if there is not any player data, so we were successful in accessing the database, but there was no data available for them, then we're going to give them some default data. So print new player giving default data. And then we'll set the player data to be equal to a new table. And this new table is going to be the contents of the default data. So we're going to copy the contents like this, Control C, and paste it down here like so. There we go. And then we're going to say just below that, we're going to set whatever the value of player data is, whether it was this new data we've just set up, or the data we retrieved from the database, we're going to put that inside of our global table up here. So we'll say data, player.userid, and we set that equal to the player data that we've just retrieved. And then finally, else, if for some reason this wasn't successful, then we'll probably put out a warning message. Warn, unable to get data for player, and then we can just put out maybe their user ID. And now here, if you're making a game, you would probably want to keep loading, maybe keep trying, or maybe eventually kick them from the game. And ideally you'd want to send a message to the player, but in our case, we'll just be a little bit lazy and we'll just kick them straight from the game. And we'll say, there was a problem getting your data. So this message will be displayed to the end user in the form of the kick message. Now, why would we want to kick the player? Well, the reason for this is if they load in and we're not able to connect to the database, so if it isn't successful, then the last thing we want to do is to provide them with default data. Because what that will mean is that they'll then have this new blank slate information saved to their account, and that will override some previous data they may have. So to avoid that happening, we really just want to kick them, and then maybe they can rejoin once our game's able to connect to the servers. Maybe Roblox's servers were having problems, but maybe they can rejoin later and they can access their old data rather than having this stuff be overwriting what they've achieved on their account, which nobody wants. So this is our load data function complete. Now we need to create our save data function. Now before we do that, we probably want to just quickly test. So we'll hit the play button and we can see down the output it says data retrieved, but then it said new player, giving us the default data. So of course we can see what's happened if we look in our script. Right, it's gone to load. It's been successful in calling the getAsync function. So it got the data retrieved. Then it was a new player, so it just gave us the default data. And probably instead of data retrieved, we should say connection success. That probably makes more sense. And we now know this is working fine. Let's now write our save data function, because at the moment, if we rejoin the game, we're going to get the same message. We haven't got anything saved, so it's just going to keep giving us the default data every time. So save data is going to work very similar indeed. So in fact, we could actually just copy all of this. You can copy all the contents of load data, Control C, Control V into save data. But the difference is, instead of calling getAsync, we're going to call the function updateAsync. So instead of retrieving data, we're now setting data. Now we still need to send the player.userid as the first parameter, but we now have a second parameter as well. So we're going to add in a comma, and this second parameter is actually a function. We can see it says transform function here. And this is what's known as a callback function. So it's something that will be called if we're able to connect. If it's not able to connect to the database at all, then it's not even going to bother running this function. But if it is, then it will run this function. And what we want to do is we need to tell it what data we want to set, what we want to write into the database. Now, we can do all kinds of ifs and checks and so on, but all we're going to do is we're simply going to tell it to overwrite the current data with whatever we have inside of our temporary session data table here, in that data table. So, because we've already loaded it into there, it should be there. So we can say return data brackets player.userid. Now we have just, of course, assumed that there is data available. So it might be a good idea to check that they actually have session data. So let's just do a check at the top of our function here. We'll say if data player.userid. If that exists, then, and we'll wrap all of this function inside of it, then we'll do all of this. Else, we would just warn no session data for player.userid. And so that's the update being done. And then if it's not successful, yet we'll try and repeat exactly as before. Now, if it is successful, then we don't need to do any of this anymore. We don't need to set or update anything else. So we can remove all of this, and instead we'll just print out data saved successfully. Now, if it isn't successful, then we don't need to kick them, but we might just warn that we were unable to save data for that player. So that's our save data function done. So now let's click play. It says new data, new player, giving default data. And now if we hit stop, the player moving event will fire. We should get a new print. And it says data saved successfully. So that's our saving data function. If we just scroll out a little bit here, you can see it in all its glory. It's quite a big function. And it looks pretty much the same as our load data function. Now, if we want these to work with our shop, we're going to need to make a little change, because if you remember, we're using this default data everywhere. Now, we no longer want to use default data. We want to use the data that we've grabbed from the data store, or the database as I've called it. So we'll move every instance of where it says default data. I've done a Control F and I've searched for default data. So then it's going to highlight them for me. And instead of it saying default data, we're going to grab it from the data table. So data, and then we'll index with the player.user ID. So that's line 100. And then where also we used it, we use it when we return the data for the remote function. So now we'll return data player.user ID again. And we're using it default data anywhere else. We're also using it in the get item status function. So we'll swap that out, just the same, data.player.user ID. And then we can actually remove this default data table altogether. We don't need that anymore, because we're going to set that over down here. And now if we hit play, we can test out our save data function. So at the moment it says connection success. And if I go to the shop and I purchase, let's say, the rocker and the samurai, and then I equip the brute as well, so I've got these three equipped, and I go and leave the game, we should see data saved successfully in the output. That's good. And then if I go to rejoin, we should hopefully see when we go to the shop, there we go, our 3 units have been retrieved from the data store and they are there in the shop. Fantastic. Now, there's one other sort of use case we might want to bear in mind, which is if the game is updated and you shut down the servers manually. What that will do is it means that the player removing event won't fire. So if this was to happen, then you wouldn't actually, there's a good chance that the player's data would not be saved if this player removing event isn't fired. So as a workaround to that, we can use something called game bind to close, which allows us to run another function if the game is being shut down. So what we're going to do is we're going to loop through all of the players and then save their data. So we'll do a loop for index player in pairs, and then we'll use the players service and use the function get players, which gets us a list of every player that's in the game. And what we want to do is call the save data function. Now we don't want to, we could just call it like this, save data player, but we can't actually yield inside of this bind to close. This fires right as the game's closing and we only have a few seconds. And if we've got loads of players in our game, it's possible that, say we had 20 players, that we'd only manage to save the first 5 or 10 players' data and the rest would just be lost. So what we really need to do is we need to make sure all of the saving happens at the same time so we can pack it in. So to do this, we're going to call task.spawn, which is a bit like spawning a new thread. So we can have multiple things happen at the same time, and then we'll wrap that inside of the task.spawn. So allow us to keep saving and keep trying those repeats, even as we're looping through the list. Another thing we might want to bear in mind is that because we're stuffing this data table with information, we're never actually removing it, which means that this data table could get really massive. And we don't need to keep data for players that have actually left the game. So inside the player removing, instead of connecting it direct to the save data function, we'll connect this to another little anonymous function. And we'll call the save data function as before with the player parameter, like so. But what we're also going to do is we'll go to the data table and we're going to get the players.userid, and we're just going to set that equal to nil because they've left the game, so we don't need to keep their data in this table. This table, of course, is just stored while the game is running, but we only need to save it on the data store itself. So that's all we need to do here. But if we do click play and I exit, it's going to make the game sort of hang a little bit because it's probably going to be trying to save the game twice. Because whenever I click play and then stop, it runs this shutting down function. So if we do a little print here, it's going to say, when I click stop, it'll say shutting down. Now, this can cause a little bit of lag. You don't really need to be having lots of saves happening, especially in Studio if you're going to be clicking play and stop a lot. So a little tip that can be useful to do is to get another service by the name of run service equals game get service run service, because this has a very useful function we can use to check if we're inside of Studio or not. So inside of our game bind to close, we can say if it's not, so if not, run service is, and you see we've got client and so on, but we're going to call the is Studio, which tells us whether we're inside of Roblox Studio. And if we are not inside of Roblox Studio, i.e. we're in an actual game, then we will save the data. Otherwise, else we'll just print out shutting down inside Studio. So it won't bother trying to save twice. So if I was to play and then stop again, we should see in the output shutting down inside Studio, and it's still going to save the game because we're still firing the player moving, but we're just not calling it twice, which is a little bit unnecessary. So that's everything done in the lobby. Now we just need to take this data that we've saved in our database and actually set it up within the game. So make sure we click File and Publish to Roblox. And then we're going to head over into our game place. So of course we go to View, Asset Manager, and back to the game. Okay, so now I'm back inside the game. And if we remember how it works inside the game GUI is if we scroll down to, I think it's somewhere in the setup, here we go, in the setup game GUI function, what we did is we created these buttons for every tower that we had in the game. So in replicated storage, I've got this towers folder which contains my towers, and we created a button just for all of them. However, really what we now want to do is just create towers for the ones that we actually own according to their individual player's data store. So we're going to need to have a data store script inside of the game as well. And what we might as well do is just copy and paste our script. So I'm going to paste in the shop server script, which is the same that was over in the lobby place. And I'm just going to rename it data store. And we'll open this up. And we'll keep the load data and we'll keep the save data function as it is. But what we don't need is we don't need to have any of this stuff to do with the shop. So get item status we don't need, and interact item we don't need anymore either. But the get data function we will require. Now currently we don't actually have a remote function called that. So if we go to our functions folder and we'll add in a remote function and we'll name that get data. And so then we'll need to actually create a variable for that. So if we go to the top of the script, let's see, we can remove this line about the tower shop. We don't need that anymore, but we'll need some functions. So local functions will be replicated storage, wait for child functions. And we'll also need our remote events folder in a minute, replicated storage, wait for child events. And so then we can get the the get data function. So get data func equals functions wait for child get data. And then we can also get the event as well for when the player exits. Remember, we created this remote event called exit game for when they click the exit button. So we're going to bind that into this function too, into the script soy. So local exit event equals events wait for child exit game. Because we're going to fire when this is fired, we're going to save the data. So rather than when the player leaves the game, we're going to have it happen when the exit event on server event, and then we'll connect to a function with the player just as before, and we'll save. Now, the reason we want it to happen when they use the exit event is because that's when we know they've actually finished the game. Because if we had it happen when they're being removed, that means we're going to be saving the data pointlessly, right? If they exit the game midway through, we're not really interested in saving any new data, and we certainly don't want to reward players for doing that. So we're only going to bother saving anything if they actually make it to the end. And so then as for our get data, instead of replicated storage, it is now our get data func is what we called the name of the variable. So now we can copy that variable for the get data function, go over to our game controller, and if we scroll up to the top where we've got all these other remote functions, we can just add that in. And in fact, just to be more consistent, I'll change it from func to function so it fits in with all of these. There we go. So now in our towers situation down here, instead of just grabbing all of the towers, we're only going to get the ones we're interested in. So we'll say local player data, and we'll set that equal to the get data function, and we will invoke the server. And now what we can do is we can loop through what towers they have. So in pairs rather than all the towers, we'll say player data dot selected towers. Because remember, we're not just interested in the towers that they own, but specifically the ones that they have selected from the store, the ones they've actually equipped to take into battle with them. And so then what we'll do is we'll check if that thing, that piece of text that they have saved in the selected tower of their data store, if that's actually in the towers folder in the game. Because it's possible, if something went wrong or we've misconfigured it, that somehow they could have let's say they had the word night saved in their data store, but we don't actually have a tower named night. So let's just check. We'll say local tower equals the towers, and then we'll say find first child, and we'll use tower word. And so then if tower, we don't need to check if it's a model, just if tower exists, then we will go and create that button for them to then be able to buy one within the game. So now if I hit play, so if we now just vote for a map, we can vote for islands, and we can see that we have connection success in the output. So we know that has loaded our data. And if I now join the game, we see we've got our samurai, the brute, and the guitarist. So we could drag, say, our guitarist in and place him here, or the rocker, and he can start dealing some damage. So we've got our customized towers, the ones that we had bought from the shop, and only my player from my data store can access them. Fantastic. So the only thing we probably want to do now is to have a reward at the end of the game. Because if you remember, at the very end of the game, we display that exit screen. So if I just go to the starter GUI and we have this end screen, if I just make that visible for a second, there it is. It looks like this. At the moment, we display kills, how much gold they earn throughout the game, and what wave they reached. But we're going to do things a little bit differently now, I think, because instead of telling them how much gold they earned, which only really applies to the game itself, we want to tell them how many stars they earned, and stars are what they're going to use to purchase things back at the lobby. So let's rename gold to stars, and then we'll change this to a bluish color, like so. And we'll make sure the actual name of the thing is stars rather than gold as well. And then inside the game controller script, we're going to calculate how many stars they have earned. So if we go to our end screen function, I'll just Control F to display end screen. Here we go. It's on line 271 for me. Now, if it's game over, if it's victory, yeah, we don't really bother which state it is, but we'll calculate the reward down here. Just before we started, we had gold before, but we'll just calculate this. So first of all, we need to get the info from workspace.info, and we're going to set the star reward equal to however many waves they made it past. So we'll say info.wave.value, and then we'll maybe divide this by 2. So if they make it to 4 waves, they'll get 2 stars. So they get half a star per wave, essentially. Now, instead of giving them any decimal waves, what we could do is we could just round all of this off. So put math.round, then that'll ensure we actually always have an integer as well. And then what we'll just check is maybe give a special bonus for if they win. So if info.message.value equals victory in all caps, then we know that they've won. Why is it victory in all caps? Well, if we remember, that's what we set it to in our round module script. So in the round module, in our start game function, if they've the game running.value, if it's still running and the wave equals 10, because we only have 10 waves, then we set the message to be victory, and that was the final message to be displayed. So make sure we're setting it to the same message that we've set here within our start game function. So if that is the message, then we're going to make stars equal, let's give them 12 stars if they win. And then down here, screen.stats, it's no longer gold, but .stars.text will equal stars, and we'll set that equal to, instead of local player.gold.value, we'll set that to simply say stars. Fantastic. And so now we've actually displayed it to the client, we could just do a quick test. So how about instead of doing 10 waves, let's just do a single wave. So wave equals 1, 1, and if the wave equals 1. Just so we can test this quickly rather than having to play through the whole game. And there we go, we're in. And we can place down our samurai. Here he is. And he's going to hopefully do some damage. Oh, and he's ran away, but we'll place another one over here. There we go. And victory! Garden lives to grow another day. And we've won 12 stars because we've reached the end of the game. Fantastic. So let's just reset those values back to 10 and 10 here. So that's going to display it to the client, but we also need to actually save this back on the data store as well, don't we? So, seeing as we've fired the exit event from here, we'll head back to our data store where we have the exit event, and we're already receiving it inside of here and firing off our save data function. Well, inside of save data, let's calculate how many stars we need to give them as a reward as well. So how about before we even attempt any of this, so we just paste it in and we'll set the stars like so. And then just below we'll say data player.user_ID, and we set that equal to be whatever stars we have calculated as. So we're setting it on the global table that's just kept while the game is running. And then we're going to update the player's data store with the new data, which includes the stars that we've just set. Hang on, I'm getting a bit carried away here. We don't want to just set all of the data straight to the stars. We need to make sure we set the dot stars. We only want to set the stars portion of the data to be stars. So I'm going to click File and Publish to Roblox here on the game place. And I'm also going to publish over on the lobby place one more time as well. File, publish over here, fantastic. And then we can head over to the website and we can see it says updated 10 seconds ago. So if I hit play, we know we're accessing our most recent update. We'll load into the game and here we are inside of the game. And probably maybe turn down this sound, background sound, it's a little bit annoying. Here we go, shop. Open up the shop and we have our units equipped as we would have expected. And so if maybe we'll buy the magician as well while we're here. So we'll have the samurai, magician and the rocker. Or maybe we'll take in the slinger instead. So we'll equip these three and we'll head off to the teleport. We'll have the countdown and hopefully once the countdown takes us off into the new place, we should be taking our data with us as well. So here we go, down we go, and we get the black screen, but hopefully the teleport's working. And here we go, new game is loading. We will have a vote for the islands. I think the islands is my favorite map. Probably had the most time spent on it, and it looks the coolest too. And there we go, I've got my slinger, my samurai, and my wizard. We'll place down the slinger. And maybe I do want sound effects after all. There we go, we get those cool jungle, I don't know, kind of tropical beats playing in the background. And we could even have our wizard character as well. Can cause some damage. And there we go. And we get a wave reward, and soon we'll even be able to afford our samurai man. Here we go, we can place him down. There he is. He can start doing some damage. Now, I did say at the beginning of this episode, it was going to be the final episode. Now, that may leave you thinking, well, what next? There are, of course, endless other things you could add into your game, but we're not going to cover every single million of them all in this series. That's really for you to figure out along the way. But hopefully I've given you all the building blocks you need to get started. For example, each of these towers contains different value objects. For example, give them different range, damage, and cooldown. One thing you could do is you could add, say, another value, some sort of buff or effect, or maybe even a hidden value. All you need to do is check in the code if the unit had the special value, and then change what it does accordingly within the tower function. So maybe instead of calling an attack function, you would then call some sort of support function which supplied temporary extra damage to nearby towers. Another thing people have asked about is having sort of defensive units that come from the base itself. You could do this fairly easily because if you remember, we've already got these waypoint objects created. Just like how for our mobs here, we loop through all of the waypoints and move them between them all. Well, for your defensive units, you just have to loop through the waypoints again, but instead of going positively, you'd have to go in reverse. So starting with the final waypoint and then moving backwards through them. That's just a few ideas of things you could do, but you'll really have to figure out how to add them on your own. Now, if you're still somewhat unfamiliar with the basics of scripting, despite making it through all of this, I would definitely recommend you check out my beginner series, which covers all of the basic concepts behind things like if statements, functions, loops, and so on, to help you really get a firm grip of all those basics, which can really help you out if you've just been blindly following along up to this point. Another excellent resource is the Roblox Developer Wiki. This contains information about every matter of the API all in one place, so you can look up a function and see what it does. There's also code samples for you to copy and run there. If you need to help or get some advice, you can of course check out our Discord server, where you might be able to find someone to help. And there is also the Roblox developer forums. Now, of course, please don't just pile into these places and ask blindly how to help, but instead make sure you have already done your research, such as going to somewhere like the developer wiki, and you've had a little bit of a look around. If you're going to ask a question, it always helps to make sure that you've got some information rather than just a blanket help question. And I should also mention that I've got a new website online at gnome.codes. There'll be a link to it in the description. It's not got much here, but it has got a tutorials page where I list all of my tutorials. And if you go to the tower defense section, I have some download links for all of the episodes so far with a Roblox place file attached for you to download and check out. But that's about all the tips for you. Now, what next for me and my channel? Well, we're definitely doing some more tutorials here. It's not strictly a tower defense series. It's not strictly a tower defense game. I'm sure there'll be other series to come, and I've already got a few other ideas in the works. So hopefully all of you guys that joined for the tower defense series will stick around for more videos to come. And if you've been sick of these videos, then you're pleased to know we'll be moving on to some pastures new. And it looks like we're about to get overrun by teddies here, so I'm going to try and quickly upgrade and put some new units down very quickly. Let's see if we can deal with this rapid teddies. Here they are, they're incoming. And I think we're going to deal with these no problem. We can take this little bit of damage. And there we go. We've got our victory end screen here. And it says the garden lives to grow another day. We've earned 12 stars, and if we hit exit, we should hopefully have our new data saved. So we'll hit exit, and it should teleport us back to the lobby place. So now it's thrown us back into the lobby place, and if we go back to our shop, yeah, we've got the items as before, and if we look at our money, we've got our stars, we've got 87. So I believe we probably had 75 when we purchased them all, and then it's given us those extra 12. So we're now up to 87 stars. So we can see that those new stars have taken effect. And there we go. That is the end of our series. So thank you so much for coming along and joining us on this amazing journey. And I'll hope to see you in more GnomeCode videos to come. So thank you for watching, and goodbye!